So good morning, class. This is your science teacher, Mr. Zhong. Today we're going to talk about the chapter 6, respiration. So you can turn to your notes, which has already sent it to you in the soft copy. So please check your mail. So I will break down this topic into 8 parts, and in this video we'll talk about the first two. So they are the first one, why do we need oxygen, which is closely related to the word respiration. So, but at first, respiration, quite a lot of students may mix up the word respiration with the word breathing. So, well, this makes sense because respiration, in fact, in Chinese called 呼吸作用. However, after this lesson, you know that in fact it is not equal to the word 呼吸. While 呼吸 in English, breathing. Okay, so they are totally different things. And the second part, we'll talk about how exactly we breathe the oxygen, or the fresh air into our lung, which is involve quite a lot of different muscle as well as the structure, which will help us to complete this process of bringing the fresh air into our lung. Okay. Okay, after bringing the fresh air into our lung, we have to send those, we have to take the oxygen into our cell. In fact, the whole process, we want to bring the oxygen into our cell. So the next one would be the respiratory surface. This is the part where perform the gas exchange. Okay, so right now you may encounter many different words, but no worry, we'll mention it one by one in the later chapter. So respiratory surface is the place for gas exchange. Place for gas exchange, and we call this as alveolus or air sac. Okay, so then we're going to mention the differences between the inhale air and exhale air. What exactly we have take from the fresh air. Okay, and the other one, the other part that we was going to study the respiration. Okay, so this is the part where study the respiration of a living organism. Okay, so if you have studied, oh, sorry, if you have studied our notes, you may found that we study both animals as well as the plants, or to be more exact, the seedlings for studying the respiration. Okay, so and then we'll mention a part called circulatory system. Okay, circulatory system in Chinese is called 循環系統. Okay, so because I've mentioned earlier, our target is to bring the oxygen into our cell. So we need the help of those blood as well as the heart. So that's why we will also mention the circulatory system as well as the heart, the function of the heart. Okay. And the last one I'm going to mention about, in fact, there's some hobbies. There's some hobbies that would uh, damage our lung, damage our breathing system, which is very bad. And eventually, we'll also mention some disease that's associated with those bad habits. So if you remember, in fact, this is not the first time you have encountered this word respiration. I wonder if you remember this old lady here. Okay, she's called Mrs. Green. So we mentioned about the 7 life processes. This is the characteristic that all living things should have. Okay, this can be found in all living things. Okay, so in fact, respiration is one of the characteristic of living things. So why respiration is so important? Because respiration is talking about the release of the energy from the food in our cell. Okay, so because we need energy to perform many daily activities, for example, just like right now I'm speaking, and right now you're listening, and when you're hungry, you're going to find food. All of this needs energy. And how do we get our energy? Very simple. So you are hungry, you're taking food, and at the same time you are breathing. So which bring you the oxygen. Okay. So to be more exact, not food but glucose. Okay. So while the oxygen is from the air by breathing. So these two combined together will give you energy, and we call this process as respiration. So that's why respiration is very important because all living organism needs energy. It's a chemical equation. So that's why you can somehow think of why all living things they need food, they need oxygen because all of them perform respiration. The reason is simple, they need energy. Okay, so this graph can somehow give you more a clear picture about the word breathing and the respiration. So let me first here clarify. The word cellular, basically, cellular is an adjective, which describes the word respiration because uh, respiration take place in cell, take, takes place in cell. Okay, or in living cell anyway. So that's why we call this a cellular respiration. Okay. So now here is the story. Sorry, very simple. So when we breathe in, okay, when breathe in. So because in the fresh air there is oxygen, okay. Oh, so it should be something like this, O2. And so we breathe in oxygen and we breathe out carbon dioxide. Okay. So inside the lung here, inside the lung here. So which would somehow there's full of blood vessel, and then we try to uh, take the oxygen to the cell by the blood, by the blood. That's why we have to mention about the circulatory system. 循环系統 because they are the one responsible to carry the oxygen into the cell. And at the end, in a place called mitochondria here, mitochondria, this is the place where the food and oxygen combines together and release energy. So respiration here was, in fact, is the process that uh, release energy from digested food, which is glucose. So please consider respiration as a chemical reaction that take place take place inside the cell. Okay, because cell needs energy because we need energy inside the cell. Okay, so this is chemical reaction. So you can see that this is the chemical equation. So at first, what do we need? We need glucose. We need glucose and oxygen. Glucose was from the food, okay? While the oxygen come from our lung after the fresh air flush into our lung, and we allow because of the difference, the gradients difference of the concentration of oxygen, so we take in oxygen, and respiration would turn these two into carbon dioxide and water, and at the same time release energy. So that's why we breathe out carbon dioxide, because respiration would itself produce carbon dioxide as the side product. This is considered as waste. Okay, at the same time, we also produce water. Okay, also produce water. So here's a table to compare the breathing and respiration. First of all, breathing, you may consider it is just uh, action, an action of a movement of a muscle that at the end would bring fresh air into our lung. So this is the word breathing means. So they're responsible for the intake of fresh air and remove of foul air. This means the breathed air, the air inside of our lung. Okay. So while respiration is much more complicated, it is a chemical reaction that release energy by combining food and oxygen. Okay, let's continue. So this is a physical action. So there's no new substance form, the physical processes. Well, this one is a chemical process, or to be more exact, biochemical process, which take place in the living things, in a cell, and this create new substance. Because if you remember, we use oxygen and food, which at the end would give carbon dioxide, water, and at the end energy. Okay, so these two is the new substance. So this is a chemical reaction. And at the end, yes, of course, energy is released while breathing does not release any energy. And breathing is why we say that it is extracellular processes, because this is take place inside an organ. Okay, we need lung, we need a lot of different things like nose, trachea, etc. While respiration takes place inside the cell, Okay, and we'll also mention about this word enzymes later uh, in the respiratory part. Basically, enzymes is a protein that can speed up chemical reaction, that speed up the chemical reaction. Okay, it's because otherwise the reaction here, the reaction of respiration might be too slow, so we need to speed up. Okay, and speed up we usually use enzymes. Enzymes can do this thing to speed up the reaction. Okay, well, because in the breathing this is not a chemical reaction, that's why we need not enzyme. Okay, and six, yeah, only happen in certain organ, while respiration in all living things we need respiration. All of them needs energy. Okay, so the story is like that. So at the very beginning, okay, our cell needs energy. They needs energy. They needs energy. Okay, however, when you need energy, so they have to perform a respiration. Respiration. However, for performing respiration, you need two uh, reactant. Okay, so they are the oxygen, which is in the air, and glucose, which is in the food. Okay, so how can we take the oxygen to the cell. Okay, so first of all, by breathing, we can bring those oxygen into our lung by breathing. Okay, so after the oxygen get into the lung, the oxygen will then absorb, or I will use the word diffuse into the blood, or to be more exact, inside the red blood cell. The red blood cell would be the oxygen carrier, and then at the end, red blood cell will go through the whole body and pass the oxygen to the cell. Well, the other way, when you're talking about food, so after the digestion, and they were being absorbed into the bloodstream again, and then the blood would bring the dissolved glucose or food substance into the cell directly. So that's why do we need food? At the same time, we need the breathing. Without any one of them, we will die soon. Okay, so you have to bear in mind this chemical equation. You need to know how to write down the word equation. Okay, so glucose plus oxygen, and this take place at the present with the enzymes in the cell, and which would give the carbon dioxide and water. So because it is a chemical equation, you just have to need to write down all the materials or substance produced. You need not to write down the word energy. Energy is not a substance. So when you write down the word equation or chemical word equation, you need not to write down the word energy. But you should know during this process, energy is released. Energy release. Okay, we just do not write it down in the chemical equation. Okay, because energy is not a substance. So far the checkpoint is first of all, respiration is the release of the energy from food in our cell, which happens in all living things. This is a chemical reaction, and all students should know it takes up oxygen, uh, glucose, okay, and so it takes and release carbon dioxide as well as water, H2O. So this is respiration. It is a chemical reaction, while breathing only involve inhaling and exhaling. Inhaling means yeah, while exhaling full check, okay, the air in and out of our lung. Okay, it does not create any new substance nor release any energy. Okay, so this is difference between breathing and respiration. So the second part, we're going to talk about atmosphere. Okay, so right now the whole story is first of all, we know uh, air contain oxygen. Air contain oxygen, and at the end, our cell needs oxygen. Needs oxygen. So the story would be what exactly happened in between. Okay, how can we bring the oxygen in the air into our cell for our cell to perform the respiration? Okay, this is the most crucial, most important part of this chapter. Okay, so let's begin. Okay, atmospheric content. Okay, atmospheric means atmospheres. Okay, 大氣層的 content means ingredient. Okay, so first of all, you should know the composition of air. 78% of them is nitrogen, which is 氮氣. Okay, about 20% of something would be oxygen, 氧氣, and this is something that we need. So the remaining one would be something like argon, carbon dioxide. Sorry for here, I can't show the complete wordings. Carbon dioxide, hydrogen, helium, etc. And also, they also may have some water vapor. Okay, sorry. They may also have some water vapor as well. Water vapor. 水蒸氣. And however, the content is quite variable and unstable for water content. Depends on where you do the measurement. Okay, I suppose here when they mention the composition of air, maybe they mention about dry air. Okay, however, if you know that air should have a water vapor, it's very simple. For example, if you drink a Coke, okay, a can of cola, you may eventually found that there's some water droplet, outside the cold can, and this is basically come from the water vapor in the air. Okay, so that's why there's some water vapor. For oxygen, not only useful for us to breathe, but also it is important for us to burn the fuel. Combustion means 燃燒, okay? So which is also support burning oxygen, okay? So when we're talking about atmospheric content in this chapter, there's something that you should pay more attention to. First of all, we are talking about respiration. That's why we mentioned oxygen. Oxygen is very important. And at the same time, because we breathe out carbon dioxide, which is the product of respiration. That's why you have to also pay attention on the carbon dioxide as well. And the last one, water vapor. So you may start to think about that, okay? For the inhale air and exhaled air, think about the air before breathing and after breathing. I mean, you breathe out the air. Is there any difference in terms of the content of oxygen, carbon dioxide, water vapor? What I mean is, do you think that there's more oxygen before or after the breathing? More carbon dioxide before or after breathing? Water vapor. Think about your breath and the normal air. Which one usually is more wet, contain more water vapor? So in order to for the oxygen to reach inside the lung, first of all, the oxygen has to pass through all these paths. And let's start from here. So please expect that you need to know the spelling and the meaning of these words. Okay, let's start. The first one. Okay, the first one, nostril. Nostril. Nostril, exactly, in fact, is the hole of your nose. Okay, so the oxygen will basically pass through from here, and then it will pass through your nasal cavity. Nasal cavity. Okay, 鼻腔 nasal cavity. Okay, after that, So it will pass through a pharynx. Pharynx is, you may consider it's the part that joining your nose except or your nose except at the same time your mouth cavity. Okay, this is the part where they meet. And then continue. Larynx. Larynx is very important because this is the part where uh, the esophagus and the trachea, larynx, they responsible to separate things in both trachea and esophagus. Esophagus we've mentioned in the food and digestion. That's the pathway for the food to pass into to reach your stomach. Okay, and then larynx brought into the trachea. Trachea, you may find that very interesting because you can see this uh, ring shape illustration. We'll talk about that later. This ring shape is in fact very important. Okay, this is special design for the trachea. After that, trachea here will branch into two bronchi, a bronchus here, bronchus. So let me write down the Chinese name. So bronchi would be 支氣管, and then which will also branch into much smaller bronchiole, 小支氣管. So at the end, each bronchiole would reach a bag-like structure, We call these as ascent in power. So you may consider each bronchiole would end it with a bag, and we call that bag as the ascent. And that is the place where the fresh air would allow the oxygen to diffuse into the blood. So when the air is going to be during exhalation, 呼出氣體, so it would using the same path, but I use the red pen, same path, and allow the air to to force away from our lung. So they, in fact, breathing and breathe out, they use the same path. And just now we've mentioned about the trachea here, the trachea. Okay, so it is, in fact, you can see some here, is the C-shaped cartilage. Okay, so cartilage here means soft bones. Okay, so this cartilage is very important. This cartilage, in fact, so first of all, trachea. So trachea, something like this. It's a long tube, a long tube, a long tube. So we breathe in and breathe out air using the same tube. Okay, so same tube. Okay, while the C-shaped cartilage, in fact, is surround these two. So why we need this cartilage? Okay, this cartilage is very important because we need to make sure that this long tube does not collapse. Imagine if you're breathing and breathe out, because this tube basically is made of muscle only. So one may consider that the air pressure may sometimes was too low, that the muscle surround the cartilage may may push into this long tube, and eventually the long tube may stick together just like this one. It stick together, okay, because of the air pressure. So that's why the cartilage, in fact, is trying to hold the shape of the trachea in order to prevent it from collapsing. Okay, if collapsing, the tube just stick together, then uh, he or she can no longer breathe anymore because the trachea was collapsed. So these cartilage can also be found in the uh, bronchus as well, but cannot found in the bronchiole because bronchiole is already too small. Okay, you cannot no longer found the cartilage anymore. So, but how exactly why the air, the fresh air, will be somehow get into our lung, and at the end, um, why we can force the air out of our lung? So, I strongly recommend you go watch this video by using this QR code. Um, After watching this video, you may find that for breathing, inhalation and exhalation. So there's two very important muscle that is responsible for this action. So first of all, diaphragm. Diaphragm. Diaphragm is this. Sorry, I should use red pen. Okay, it's this structure. This purple one. This purple structure. So this is diaphragm. This is diaphragm. And at the same time, there's another muscle which did not show in this graph. It's the one in green. And this is the sorry, sorry, let me write again. Intercostal muscle. That is the muscle in between the rib. Okay, in between the rib. Okay, so these two muscles responsible for the whole action why the air would be uh, inhaled and why the air will expel during exhalation. So please watch this video. In order to facilitate the learning uh, for the inhalation and exhalation, I have to introduce a law to all of you, the Boyle's law. Okay, so this law is mentioned about there's a relationship between the pressure of a gas and the volume of the container containing that gas. Okay, so you may consider this diagram here. Okay, so imagine inside there's 5 dots, and these dots they are gas particle. Okay, they're gas particle. So, and as you have learned in the particle model, all particles keep moving. So, not to say the gas particle, they're moving in any direction randomly, continuously. Okay. So, when they hit the wall, so the wall would eventually feel a force, and we call this is the air pressure. Air pressure, because the particle exert a force on the wall. Okay, force on the inner wall, inner wall of the container. Okay, so imagine if I reduce the volume of the container. So originally originally, they can move a much larger area, the one in green, a much larger volume, sorry. But right now, you can only move in the region, in the red one. So you may think that they have a higher chance to hit the wall because they are the volume, the space that allow them to move is less than before, hit the wall. So that's why the air pressure will also increase. So Boyle's law very simple. Basically, this mentioned in conclusion, they mention about these two things. If you increase the volume of a container, where then the air pressure inside would reduce. Vice versa, if you decrease the volume inside, then the air pressure inside would increase. Okay? So remember this relationship. Now let's come back to inhalation. Inhalation is a process that when the fresh air is breathed in, fresh air breathed in, okay, into your lung. So why we can breathe in the fresh air? As I've mentioned before, pay attention on these two, the diaphragm and the intercostal muscle. So during inhalation, both of these muscles would contract, okay? So diaphragm, when diaphragm, it was in relax, it is in a shape called dome shape, okay? However, when it contract, it is flattened. It's flattened. So imagine, so the diaphragm pull down. This is diaphragm. And intercostal muscle as well. So intercostal muscle. Intercostal muscle, they contract as well. They also bring up the whole rib cage. So this would bring the rib cage upward and outward. So these two actions would both increase the volume of the lung. Okay, increase the volume of the lung. So this volume is larger than before. So how does it affect the air pressure inside? So as we have just mentioned just now, when you increase the volume, the air pressure would decrease. So that's why here show a minus. Okay, so when the air pressure is lower than the atmospheric pressure means the pressure outside. Okay, this means outside. Okay, this means outside. So what would happen? So because of the pressure difference, so remember, air always travels from high pressure to low pressure. Okay, so that's why the air is drawn into the lung. The air is rushed into the lung because the pressure here, air pressure, is higher than the air pressure inside the lung. And because of the air rushing, so that's why it would also increase the volume of your lung and increase in the alveolar space. makes your lung looks bigger. Okay, that's why the volume larger again. So in this part, you have to pay attention. First of all, this is because of the muscle. So the muscle, including the diaphragm and the intercostal muscle contract, which brings to the increase of the volume of the lung, which would causing the decrease of air pressure inside the lung. And eventually, what will happen? Air rush into the lung. The fresh air rush into the lung. Okay. So in fact, lung you may consider in this case is quite passive. It is not actively as a muscle which going to expand by itself. Okay, but just uh, as a very passive part because of the muscle movement. Okay, vice versa. In exhalation, when you breathe out. Okay, so in this process, both diaphragm and intercostal muscle would relax. Okay, so when diaphragm relax, it will go back to its dome shape. Dome shape. Okay, so this would push push towards the lung. And at the same time, the intercostal muscle in the relaxed mode, it will also bring the ribcage backward and inward. Okay, and making the lung volume decrease. Okay, this is very important. So this this is the cause, and this is the result. And this result will bring increase the pressure inside the lung. Okay, this is higher than the atmospheric pressure. When it is higher than the atmospheric pressure, which would force the air inside to rush out of the lung. Okay, that's why the air is forced away out of our body. Okay, so basically it's similar to inhalation, but due to a different relaxation of diaphragm as well as the intercostal muscle. Okay, so here is some sharing uh, for how our system to clean the air. So in fact, air contains oxygen, but however, it also contains other different particles, and some of them may be harmful to us. Not only to bring some solid particle, but also they may also bring with some bacteria. Okay. However, in our body, there's certain mechanism to prevent this for preventing us from getting infection. So first of all, the most common one, I guess, would be the hair. Okay, so these here in fact help us to filter the large particle, which you may find that uh, when you're going to clean your nose. Okay, well, even some dust particle, they are too small, they may skip or the air cannot filter those very tiny dust particle. Okay, moreover, there may be there is some bacteria. Doesn't mean that our lungs really easily get infected by these virus or bacteria. Well, luckily, in fact, uh, you know, on the surface of the air tract, Okay, let's say this is the air trap, and here goes to the lung. Okay, so normally we breathe in this way. Okay, this is the way how the air pass into the air trap. Luckily, on the surface, there's some tiny here. Okay, there's some tiny here. Okay, and this tiny here requires as a cellar. Okay, so which means that this thread is some tiny here. Okay, so what's so special about cellars? So they would try, they would have just like a waving motion, a waving motion. So they're trying to push out of the lung. Imagine if there's, let's say, some particle, okay, being attached on the wall. So it would be very troublesome if we just allow these red dots stay in their air trap. However, with the function of a cellar, those red particles will eventually push, push out of our lung to protect our lung. Moreover, on the surface uh, on the cell, so they're able to make some mucus. Mucus is some sticky fluid or liquid, for example, here. Okay, so this would help, in fact, to trap something something you do not want, like dust, bacteria, and virus. Okay, so which can help to protect you, and with the help of the cellar, eventually this mucus will bring up, and you can either cut it off or swallow it. Okay, so that's why this mucus usually contain a lot of germs, bacteria. Okay, and also this mucus is also very important because it keeps the air passage moist. Moist means wet. So it is very important to make it wet because it helps the diffusion, help the oxygen diffuse into our bloodstream more easily. And this is also the reason why usually our breath has a lot of water vapor because of this moisture. Okay, so this is a checkpoint. So first of all, breathing involving inhalation and exhalation. Okay, and why you can breathe in the air because of the contraction of two muscles. So the diaphragm as well as the intercostal muscle. These two action or movement will cause an increase of the volume of the lung, which will lead to the decrease of the pressure, lower than the atmospheric pressure, and that's why the air outside would rush into the lung. This is the inhalation. Vice versa, in exhalation, the diaphragm intercostal muscle would relax, and that's why you will find that it would be a little bit harder for you to breathe in than breathe out. Because when you breathe in, when you inhale, you're basically contracting your muscle, which takes up more energy. And when you perform exhalation, all the muscle relax, you will find more comfortable and more easier. Okay, so because of this relax would cause the decrease of the volume, and that's why the pressure inside would increase, and eventually the air would force out of the lung. Okay. Okay, so far we have mentioned about how we get the oxygen into our lung by using inhalation, that's breathing, okay, breathing. And then starting from next video, we're talking about, okay, so at the alveolus, okay, which is a part which is still inside the lung, okay, inside the lung, how the oxygen would being diffused into the blood, okay, because at the end we want to bring the oxygen into the cell. Okay, so far we've complete part of them. Okay, so we complete this part and this part. Next video we're going to talk about talking about how does the oxygen get into the blood. Okay.